Number 10, we're trying to figure out if it converges or diverges. So nth term test will tell us that we've got 2, 3, 4, 5. So I've got a 5th degree polynomial on the bottom, 3rd degree on top. So as n goes to infinity, it's going to equal 0. So because if you get 0, you have to try a different test. If you got anything but 0, then it would diverge. So let's look at the n behavior model of this. I've got 5n cubed on top, and if I distributed all these out, I'd get an n to the 5th on the bottom. So you could compare that to be 5 over n squared, or if you wanted to just make it 1 over n squared. These are going to probably behave the same. So you can see I'm using the limit comparison test here. So if I find the limit as n goes to infinity of the original, that's not going to be much fun to figure this out, over the model that we're going to compare it to. If this equals a number, then they're going to behave the same. Alright, so 1 over n squared, I can move that to the top, so I get 5n cubed minus 3n times n squared over, maybe I'll start distributing here. Alright, so n's going to infinity. So distributing the n squared, I get 5n to the 5th minus 3n cubed over n to the 5th plus some other stuff. So I know my leading coefficient is just going to be n to the 5th, and they're the same degree on top and bottom, so 5 over 1. So we're just going to get 5. You could use L'Hopital's a bunch of times, or just recognize that they're the same degree, so it's just the ratio of the leading coefficient. So we get 4 or 5. So that means that they behave the same. So now we need to know, because of the limit comparison test, so now we need to know if this converges or diverges, because that's what we're comparing it to. And we know that this converges because of p being 2, which is greater than 1. So it converges. So then the original series would also converge because they behave the same, because we got a number there. So using the limit comparison test, it would converge.